So we move now to features of progressive waves. What are the properties that describe a progressive wave? Under features of progressive wave. Number one is displacement. Remember, we have said that progressive wave is a means of energy transfer due to vibrations of particles. The displacement is the distance of vibration of a particle. Is the distance of vibration of a particle from the equilibrium position. From the equilibrium position. Equilibrium position means the rest position when the medium is not, or when the vibration is not disturbed. So when you set up the vibration of the particle, the distance vibration of a particle from the equilibrium position is what is called displacement. Number two, amplitude. So basically we represent amplitude with A. Amplitude is the maximum displacement from equilibrium position. From equilibrium position. So for example, if you have a wave profile in which we are sketching the graph of displacement of the particle, maybe against distance covered by the wave, and you have something like this. You have several displacements, but only one amplitude. So 1, 2, 3, they are all displacements of the particle, but only 3 is the amplitude. So amplitude is the maximum displacement from the equilibrium position, either above the equilibrium position or below the equilibrium position. That is amplitude. Next, period. Symbol for period is capital T. Period is the time taken. Is the time taken for one complete oscillation. For one complete oscillation or cycle. Okay? So if, for example, if wave completes n oscillations or cycle, n oscillations or cycles in time t, then the period is the time taken to complete one oscillation. That becomes t over n, which is measured in seconds. It completes n number of oscillations. It could be 40 oscillations in a given time. The time taken to complete one oscillation is the period. That becomes t over n. We call this one equation 1 here. Then number 4, frequency. Frequency F is the number of oscillations or cycles completed per unit time. Per unit time. So, also referring to this, if the wave complete n oscillations or cycles in a time t, frequency will be the number of oscillations completed per unit time. So this is measured in per second, which is referred to as the hertz. Okay? Alright. So this is equation 2. If I compare equation 1 with equation 2, comparing 1 with 2, I can say that if the wave completes one cycle or one number of oscillation, the time taken to do that is the period. So frequency is the inverse of period. One cycle completed in a time of period. So So, consider the wave profile shown below. Consider the wave profile shown below. Where we plot it down for displacement in meters against time in seconds. And we have this. This is 2, 4 minus 2, 2, 4 minus 2 minus 4. 0, 5, 10, 15, 20, 25, 30, 35, 40. Determine 1 period, 1 amplitude. Determine for the wave 1 amplitude. What is amplitude? Amplitude is the distance, is the maximum displacement from the equilibrium position. So the amplitude is 4 above the equilibrium position or 4 below the equilibrium position. So amplitude is 4 meters. Period. Period is the time taken to complete one cycle. From here to here is half cycle. From here to here is another half. So the period is 20 seconds. So one cycle is completed in 20 seconds. So I can say 2 cycles completed in 40 seconds. So time taken to complete one cycle is 20 seconds. 3. Frequency. Frequency F is 1 over period. So that becomes 1 over 20. That is 0.058. Okay?